Hello, I'm Becky Lovelock. You might recognise me from some videos, online workshops that I've done for the company PD for Maths, and also I've run some Cambridge workshops all about these new textbooks fairly recently. So what we're going to do in this video is I'm going to go through and provide a bit of extra help and guidance for teachers in implementing the course using the Cambridge resources specifically, and we're going to look at covering chapters 1 to 5. A good extension class could start at chapter 3 because chapters 1 and 2 are essentially revision, and we talk about that a little bit in the video. Note that Year 11 Advanced and Extension 1 are all in the same book because the two courses are very tightly integrated, but they can be separated out if necessary. And basically what you have is that the Advanced course has been retained, those chapters from the Advanced book, and they've been extended where that's appropriate. And then the Extension 1 material has been added in 6 separate chapters spread throughout the textbook. There's a document in Teacher Resources with the interactive textbook which lists all of that extra material that's been added in the advanced chapters. Let's get started. So let's talk about the exercises that we've provided. It's important to note we wouldn't want any students sitting down and just bashing through every single exercise in the book all the way through it. The idea is that they're very long exercises and you might dip into them a little bit now, a little bit later in the course, maybe even a little bit right before the HSC, so that there are plenty of questions there for them to do. There's the same sections that were in the previous books. We've called them Foundation, Development and Enrichment here. Let's look a little bit more at what that actually means. So the foundation questions are a little bit easier than in the previous book. They're very much about consolidating the information that the students have just been given. So basic questions where it's just rote practice to get really good at it. Once they've done that bit, then they'd move on to the development, and it might be with some students you just go straight in at the development level and don't really bother with the first bit. Depends on your class. This idea is we're going through from the basic advanced level to more extension 1 level questions. And towards the end of these sections, you're talking about some relatively hard questions, but not quite as hard as the enrichment questions. The enrichment questions, if you are just studying Extension 1, there is probably no need to use the enrichment section unless you have students who are twiddling their fingers and want something else to do. But if you have students that are intending to do the Extension 2 course, I'd strongly encourage them to be trying most of these questions, or certainly a lot of these questions. So what we're going to do in this video is to go through the PDF of the chapters 1 to 5 that you've been given and provided by Cambridge. Chapters 1 and 2 are very much revision. So we're going to really quite brush over those, but just talk about them briefly and how you might cover that material at the start of the year. And then look much more closely at chapters 3, 4 and 5, which is where the material from that you haven't met previously starts. We're going to look at what the author's reasons are for the way they've put these chapters together. We're going to look at the syllabuses and which parts are covered where, by which bits, how that fits together. And also we're going to quickly mention the NESA topic guidances were released in December 2018. And there are a couple of implications, a few implications from that in terms of how you might deliver some aspects of the material. It's what we might call the elephant in the room. Let's look at chapters 1 and 2 then. The very first part of the functions topic in the advanced syllabus, F1.1, is algebraic techniques, and this is essentially revision of stage 5 material, but plenty of students need this bit, so we have formed it into 2 chapters. It is important to spend some time making sure that students know this material, but you'll find that index laws and surds are also covered in 3G, 7A and 7B, and quadratic equations will also be met in 3D, E and F, as well as in other places throughout the course as well. So it wouldn't do to spend too long on them at this stage, but it would depend on the class that you have. One way of covering these first 2 chapters might be to just briefly brush over them and then do some sort of exercise that ensures that you are convinced that they have good
grasp of that material. So a classic example might be something like a traffic lighting exercise. So how that works is you would have a sheet of the different types of questions. You could use the chapter review, for example, and students work through that, and they indicate to you, not necessarily by doing all the questions and then you marking all the questions, but them saying green light meaning, yes, I could do these standing on my head, it's no problem. Amber light meaning, yeah, I can do them, but I'm not 100% confident, could you have a look at them for me? And red being, I have absolutely no idea how to do these. And if you were to do an exercise like that at the start of the year with your class and then collect in that information, you'd get a really good overview snapshot of where each student in your class is. You can also do that in class by just putting questions up on the board and getting them to do thumbs up, thumbs down, etc. But it's a nicer, more private way of doing it where students don't necessarily have to let everyone else in the room know how they're feeling about it. Mini whiteboards work is always a fun thing to do. So we're talking about just having some A4 sized whiteboards that the students can use. And if you don't have any of those, you can actually just laminate an A4 blank piece of paper and use that. Of course, it needs you to have enough board pens. You may or may not be able to persuade your school resources department to give you those. But the idea here is you put up a question on the board, the students quickly write down their answer and they hold it up, and you get an immediate snapshot of who in the class is getting it done within 2 seconds if you're writing the question on the board, and who perhaps takes that a little bit longer or perhaps doesn't put the answer up. And it's quite a fun activity. Again, it depends on the confidence of your class. If you have anyone whose confidence is a little bit wobbly, you might want to think about how to handle that. Maybe you just simply get them to write it and have it on their desk and you stand in the middle of the room and have a look around. Whistle-stop tour of common errors is a nice way to go. So there's lots of sheets on the internet for that if you search, and here's a quick snapshot of one of them, just making sure that they really understand the common errors that can be made and how not to do it. And also just working through the chapter review exercises individually or as a group. Either of those might be nice, or just in partners, pairs. There's a difference between the advanced book and the extension 1 book in chapter 1, even though chapter 1 occurs in both books. They're fairly subtle differences, but I do go through in this video what those differences are, and hopefully that will give you some insight into what the authors feel is the step up that should be made from an advanced student to an extension 1 student. So here's an example in 1b, expanding brackets. These are the questions that have been added to the extension 1 book that are not in the advanced book. So we're talking about applying something to do with expanding brackets, but not in an immediately obvious way. So having to use the knowledge you've got, but just think about it a little bit harder and bring in the idea of proof of an identity as well. These are the lists of all the extra questions from chapter 1 and chapter 2. You might want to pause the video there, take a screenshot and print that off, or just jot it down somewhere. As I say, looking at those questions hopefully gives you some sort of insight as to what the authors feel the important extra bits are for extension 1 students to have. There are a few other differences, and one is the inclusion of this example in chapter 1, section H. And what they've done here, there are 2 other examples above this which are both doing the completing the square, but don't have it being a negative and therefore it being impossible. So they've added that extra bit in with an equation with no solutions for the extension 1 students. Doesn't mean it won't be there for advanced, it just means they're really flagging it more with the extension 1. In the advanced there are questions like that in the exercise. They're suggesting that a deeper look at the proof of root 2 being irrational could be extended out to the root of a over b being rational if and only if both a and b are rational and are not square numbers. That little extra bit's missing off the bottom there. It's in the book, and that's in section 2C. That's actually all there is extra in chapters 1 and 2, so it's not a huge amount. Chapter 3 then is also in the advanced book, and as we go through this one in more detail, I'll explain to you the extra bits that there are. So here's the overview of the chapter. Let's break down how they've constructed that a bit more. So here is the topic from the syllabus, F1.2, introducing the functions. And basically the chapter is bookended by 3a and 3b at the start and 3i at the end, which is about functions and the notion of functions, relations and graphs. So for 3a, we're looking at the idea of what is function notation, ordered pairs is a relation. So it starts off introducing it using a function machine and tables of values. Tables of values are noted. And introduces the fx notation. 3b then extends that out to a graph. So we've added in there, understand the concept of the graph of a function. And also understanding that a vertical line test is what we use to identify a function, and that comes in 3b as well. So understanding the difference between a relation and a function. 3i at the end talks about one-to-one, one-to-many, many-to-one, many-to-many. And it also introduces the idea that solving f of x equals k is to do with looking at the intersection between the line y equals k and y equals f of x. And talks about the horizontal line test in terms of determining if a function is one-to-one. That will become important when they get on to chapter 5. So it's important to note that 3i particularly here prepares the way for the extension topic of inverse functions. Chapter 5, you should note, is only in the Extension 1 book. It is not in the Advanced book. It's an extra chapter for the Extension 1 course. So let's look at 3a and 3b in a bit more detail. So within that we've got the function is a rule. Here's an example that you might want to focus on. The idea being of substituting pronumerals into a function. So a or a plus 1 or a plus h, for example. That's a relatively new idea for students, depending how far you went with them at stage 5. That f of 2, for example, is a much more straightforward idea. The f of then an algebraic expression is a bit trickier to get their heads around, so lots of that practice in this chapter. And this example is an important one, example 4. The idea that many functions have this natural restriction on their variables by the nature of the question, such as this one with the snail, Sadie the snail. These are the questions that I would pull out of the exercise at the end, as making sure all students definitely completed these questions. And these are the questions that are not in the advanced book in 3a. So the ones that the authors deem are important to set you up for that Extension 1 level. 3b, got the graph of the function and the definition of that it's a set of ordered pairs satisfying a condition, and then the domain and the range. So the idea of it being the x and the y axis, and what the natural domain is of a particular function. And here's a question I'd pick out of the exercise to help with that focus, finding the natural domain of these functions. There's also the relation is in 3b, and the vertical line test, determining if we actually do have a function or just a relation. This example could be a really good one for that, getting this idea of the line test. And here's a similar question from the exercise that students could try. That could be a mini whiteboard or similar exercise. And this is the list of questions that are not in the advanced book for 3b. At this point, let's have a look then at 3c to h. So that's the middle bit. As I said, it's chapter 3 is bookended by this theory of graphs. But 3 to h covers all the technicalities, the nuts and bolts of working with functions. And basically what we've got is in 3C, these bits are covered, which is linear graphs. In 3D, we then move on to quadratics. 3D, E and F are all quadratics. 3D is about the basic idea of quadratic functions, zeros and roots, axis of symmetry. 3E is then continuing that with quadratic functions, completing the square. And 3F then adds the quadratic formula and also the idea of the discriminant and referring to f of x equals k. So we've done linear, we've done quadratic. 3G then brings in other types of graphs. So equations of circles, equations of semicircles, and higher powers of x, cubic functions. Then 3H goes on to consider exponential functions and rectangular hyperbolas. It does look at their limits and asymptotes at quite a basic level, but it does also relates this to direct and inverse variation. It's important to set up that limits and asymptotes correctly at this point, particularly for Extension 1 students. So looking at that in more detail then, 3C we have the linear functions and sketching linear graphs. Talk a little bit about horizontal lines and vertical lines. And of course what's important to note there then is that if you have a vertical line, that is a relation but it cannot be a function because it does not pass the vertical line test. So that's something you should really make sure you focus on for students. Here's an example that would be good to illustrate that. And here's a couple of questions from the exercise. The questions not in the advanced book for 3C are listed here. And we move on from that fairly rapidly to 3D. Now, using the language of zeros and roots correctly is going to be very important throughout this entire syllabus. So make sure the distinction about roots, zeros are made. It's not strictly observed as it says here, but it is important to make sure that we do get that terminology correct in our own minds, how we're working with the students, so that they don't get confused about it in whatever way you refer to it during the course. This idea of a parabola and all the different things you need to look at for it, which way is it up, the y-intercept, the x-intercepts or zeros, the axis of symmetry, the vertex and so on, making sure that we've got all of that information. When is it going to be hard to find that information? When is it fairly straightforward? But to always have those 5 ideas in their head, I need to know this, 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 this and this. Questions from the exercise that help illustrate that. And the extra questions that are not in the advanced book. There's quite a few in 3D, and you'll start to find that there are more as we get further into Chapter 3. One of the reasons for this is we really need to set students up with these functions, their understanding of functions as being very, very solid for calculus, and particularly the higher level calculus they're going to be doing in the Extension 1 course, Extension 2 courses. So lots of harder questions here. 3E then, starting quadratics, completing the square, finding the zeros from completing the square. An example with no zeros and an example with 1 0, this is a good one to look at. So they've got both. The example before that is one with surds, and it'd be good to look at one like that as well, that would be good. And here's a question that goes through that for them nicely. And a huge list of questions that are not in the advanced book for this exercise. The quadratic formula then, and its link to the axis of symmetry, is important to make at this point. And making sure we are clear on the use of the determinant, positive, negative, equal. The example illustrates the discriminant use here. It also asks to think, there are other ways of doing this. We don't want students getting into the idea of, oh, I always do this every single time without thinking. That's the last thing we want. So this example is a very nice one that says, is there another way of doing this? Yes, there is, actually. It's quite straightforward if you think about it. Here's an example from the exercise and the questions from the advanced, that are not in the advanced book. Moving on to 3G then, and higher powers of x. I've highlighted here what I think is really important to note. Get the idea in students' heads of the fact that y equals x cubed is this shape as shown here on the graph, and y equals x to the 5, x to the 7 is similar, but as the index increases they become flatter near the origin. And that's an interesting idea to explore with students. That could even be a bit of a longer lesson exploring that in more detail, perhaps using something like Desmos. Talk about a horizontal inflection, although that's the first time they'll have met the word inflection, unless you've happened to mention it at stage 5. But use that language because it gets them used to it, ready for later on. Fourth power of x and even powers make a similar point. And then talk about polynomials in general. And the index of the power with the highest index is the degree of the polynomial, and that is related to the graph shape. Here's a question from the exercise that gets them to state whether the function is a polynomial or not, find its degree and the coefficient of the x. So just getting that idea of what the polynomial is and how you might do that. And I'd then add to that perhaps getting them to just quickly sketch roughly what they think that might look like. Not exactly, not with intercepts and so on, just the overall shape. What is that going to look like, do they think? Any ideas at all, then check it on Desmos. Cubics then, that have already been factored, and indeed polynomials that have already been factored. The syllabus only refers to cubics that have already been factored. So do talk about that a bit and how that's going to impact on your x-intercepts and the zeros. Same thing, x-intercept zeros. Here's an example that goes through that and also puts in a table of values. We left the table of values behind for a minute, but tables of values are important, and actually here we have a table of test values dodging around the zeros. So just making sure that we've got these zeros in the right place, and getting them doing this sort of thing is going to set them up really nicely for calculus. There's a question from the exercise where you can get them to practice that. And then move on to the function y equals the square root of x. So the idea that this is half a parabola on its side. So we're talking about y equals square root of x as they mentioned in chapter 2. You go back and perhaps remind them of that at that point. Means the positive square root of x. So that's the upper half of this parabola. And talk about that being a function. What about if it was plus or minus root x? And then the circle. So they may have met circles previously in stage 5. So talk about the circle for a minute and then talk about the fact that that circle graph would obviously fail a vertical line test, so is not a function, it's a relation. And here we've illustrated how you could actually have two different things that each were functions, the positive square root and the negative square root, rearranged from the original equation of a circle. Now, important to notice that at this point, in this chapter, they're actually only talking about circles that have centre the origin and semicircles that have centre the origin. Other origins are covered in 4a. Because in 4a we have translations and transformations indeed of functions, and that's where it naturally comes out of what you're doing, that you've got the original circle centre the origin and you've translated it to wherever the new centre is. Here's a question from the chapter, and these questions are not in the advanced book. H then, exponential functions. As I mentioned earlier, you want to talk about the limits and the asymptotes. start to get them to see the notation, even if they're not necessarily using it yet at this point, to just talking about the notation for limits, talking about the difference between a negative infinity and a positive infinity. And the same for rectangular hyperbolas. You could even get them doing x approaching 0 from the right, x approaching 0 from the left, drawing a few diagrams on that, considering a few Desmos graphs. Here's a nice question from the exercise to practice some of that. Work with some of that, perhaps even discuss as a class. Then direct and inverse variation comes into that from the two graphs. So defining that in terms of k being the constant of proportionality. And here's a nice question on inverse variation from the exercise. One of the nice things about this is that it has letters that are not x and y. And as you'll see in a moment, the topic guidance mentions that. So it's important to try the odd question where you have not just got x and y. And here's the questions not in the advanced book. So finally then, we have the other bookend, 3i, returning to the theory. We had the vertical line test already, so now we've got the horizontal line test as well, and a quick cap of 1-to-1, many-to-1, and so on. Here's a nice table that's in the book that just summarises that. So really try and get students to get their heads around this idea of how we can test for each of those types. And here's a question that would help. And there's just one question not in the advanced book for 3i, number 6. So now let's look at the elephant in the room. So the topic guidance for functions. Things that we've had, when we've had a look through, we've just thought, that's something we need to be aware of. And this is one of them, that the fluency in the use of symbols other than x and y and notations other than f of x should be used. And they've given a few examples in the topic guidance. So here's where they occur in chapter 3. You've got some questions and a couple of examples where that is done. So important to draw students' attention to that and just make sure that they are fluid in not always having to use the x and y, that they can cope when you don't. Most of the time I would, but just make sure that they don't fall apart if you don't have an x and a y. It says in the topic guidance for function, continuity and discontinuity are to be treated informally at this stage in the course. The issue being the continuity isn't actually mentioned in the functions section of the syllabus. It is mentioned in the calculus section, and therefore it's discussed in chapter 9 on differentiation. That's where that's brought in and discussed at quite length. It's also, we just do discuss it briefly in chapter 5 when we're considering tables of functions. So it's there, and students will be aware of it. I don't think it's anything we need to particularly worry about at this point. Now, a large issue is that bracket interval notation has often been said to be a feature of this new syllabus. Although the advanced syllabus simply says interval notation, it doesn't say bracket interval notation. In the glossary, it defines interval notation as bracket interval notation rather than inequality interval notation. And so the implication is perhaps there that bracket interval notation is something students ought to be exposed to. Notice we are told by Nessa that the glossary is not part of the syllabus. The topic guide for functions doesn't mention brackets interval notation. It doesn't have any examples that use bracket interval notation, and indeed none of the as yet published topic guides for advanced or extension 1 use bracket interval notation. So what do we take from that? Oh, we are also told by Nessa that the topic guides are not part of the syllabus. So the only place in the syllabuses that bracket interval notation is mentioned is the glossary of the advanced syllabus and in the main body of the syllabus of extension 1. So I think we can conclude that bracket interval notation does need to be taught, but we could also argue there is no definitive requirement for it to be taught in year 11. So it's not in our Year 11 book. We've introduced it in Chapter 1 of the Year 12 book, and the reasons we did that are as follows. We feel that it's very easy to get students confused between the point 3.5 and the interval 3.5. As you can see, they look identical. And whilst students are still at a very new point in the course, we'd rather they kept with their old notation whilst we introduce the new concepts. Then we can worry about a different notation. Domain and range are only just being introduced in the context of these variables x and y, and 3.5 doesn't require us to say x or y. So when you write an inequality interval, then we would need to have the x or the y in the middle, or indeed other letters in the middle. But 3.5 doesn't specify x or y, so while students are still learning what domain and range mean, it makes sense for them to refer to the x and y to establish that they are clear on that in their own head. Using the less than or equals or less than inequality signs to understand these intervals is a bit more powerful, and changing this to parentheses or square brackets later on will be quite straightforward, but they're familiar with those ideas of less than or equal to or less than, whilst we are understanding this idea of domain and range, what to include, what not to include. Quite a big thing is actually when we have to combine two intervals. In an inequality interval notation, we're used to saying, so x is between 0 to 3 or x is greater than 6. But in interval notation, that would actually be written as a union of two sets. And union is quite a complex concept. It's introduced and discussed as part of the syllabus in Chapter 10, Probability. And once they've seen that chapter and they've got to grips with the idea of union, then that will become a much easier path to take for students to make that step from writing it in the inequality interval notation to writing it in bracket interval notation. And finally, we feel it's just a little bit too early in the course to use infinity, because we really need to talk about limits a bit more there. And of course, if we've got an open-ended one, as I have here above, 6, infinity, we need to really understand what we mean by infinity, or what we are attempting to mean by infinity. So let's just go over what we've covered then in Chapter 3. So this is the topic from the syllabus, F1.1, F1.2, F1.3, F1.4 comes on the next page. So just to show as a quick screen snapshot of what we have covered, we have this first part is mentioned in Chapters 1 and 2, and a little bit in 3D to G. Our bookends cover this part of the introduction to functions and this part. Our middle bit, our nuts and bolts, covers this part down the bottom here, over here and here, and here, and here. This part here is covered by both some of the nuts and bolts and some of the bookends. And this part at the end here is also covered by some of the nuts and bolts. So what's left? And where are we going to cover it? Well, this part is covered in Chapter 4. We're looking at that in just a minute. This part also in Chapter 4. And this part is covered in Chapter 5 and Chapter 9. And the parts over here are covered in Chapter 7 on the coordinate plane. 1.4 then, F1.4, we've got some bits of the nuts and bolts in here. And then we've got Chapter 4 covering the absolute value function, and Chapter 4 reflections and symmetries covering those bits in the middle. And that's the whole topic. So let's look at Chapter 4 then. It's just 5 parts to Chapter 4, looking at transformations of graphs. It's nicely built, this chapter, and all flows in each part flows into the next part really nicely. So for A and B. This introduces 2 transformations of the graphs, translations and reflections. We've just talked about which part this does, so it unifies things. It covers F1.4, but actually it also touches on, doesn't cover it completely, F2, which is in year 12. I don't think we could say that we're teaching it then. Obviously we're not teaching it then because we're not covering all of it by any extent, but it just starts to touch on it because the idea that it unifies things, it brings this together, which is what we are aiming for. So putting that together with the idea of using reflections. We're discussing all translations of known functions, and we're also going to relate that to the completed square form of a parabola that we had in the previous chapter. And for part B, we're doing the reflections and combining a reflection in the x-axis and the y-axis to get a rotation of 180 degrees, and maybe you can see where that's going with where we want to go next, which is even and odd functions. So 4C introduces odd and even functions in that geometric context and then also considers them algebraically. What 4D does then is to take the absolute value function using those reflections that we've just had, and it considers the algebra of that goes along with it. And then 4E puts together composite functions, including those ones we've just covered then, and also looks at the domain and range of those composite functions. So in more detail then, 4A, we're talking about shifting or translating right and left, up and down, what we do with the equation of the graph to do that. And here's a nice example that looks at that completing the square. Actually, it's a cube, is it not? It's not completing the square, it is a cube. And how that has been moved from the original cubic graph of y equals x cubed. And then linking that to the idea of the completing square and the vertex. And this is a nice question from the exercise that helps with that. The only extra question in the Extension 1 book from the Advanced book is question 13 in 4A. That is it. So all of this is stuff that is covered also in the Advanced book and by advanced students. Go over the reflection in the y-axis and the x-axis and how that changes the algebra of the function. And this idea of the rotation of 180 degrees around the origin, replacing x by minus x and y by minus y, and that's what happens overall. And here are some nice questions on that. Question 5. So 4C then goes on to look at even and odd functions in terms of their symmetry, so the geometry of that, and then says what it is algebraically in terms of f of minus x is f of x, or f of minus x is minus f of x. Notice that we talk about the rotation of 180 degrees as also being point symmetry in the origin. And then a quick test for evenness or oddness, or neither. A couple of questions to help the focus. And then moving on to absolute value. So defining the absolute value and what we mean by that, and showing the graph of y equals the absolute value of x. And then sketching graphs like y equals the absolute value of ax plus b. A lot of Desmos work could happen here. Also goes through the identities for absolute value and does a bit of work with those. Nice numerical examples and so on would be good to go through there. And I've pulled out some questions from the exercise that I think would really help that. Particularly question 19 would be a nice challenging one. And again could be done with the answers then going up on the board using some sort of Desmos equivalent or Desmos itself. Moving on to composite functions. I definitely worked through a few examples of this with them because we already covered in the start of chapter 3 that we want to focus on this idea of putting algebra into a function. And essentially that's all we're doing here. We're taking the algebra from one function and we're putting it into another function. So as long as you've really got that solidly from 3a, this should follow on fairly easily afterwards. The domain and the range is a little bit trickier to get hold of. Here's a nice question that helps. Now looking at the topic guidance then with regard to chapter 4, that elephant's back in the room again. This is something that is important. It says in the topic guidance, work on composite functions could include finding the composite of the same function applied twice. And then it says this should be notated as, and gives particular notation. Now, the issue here is that in 4e, questions 1 to 8, we've got finding the composite of the same function applied twice, but there are no examples where that notation, f with a little o, g of x, is used. But we do mention it on page 54 of the textbook, and here is the quote from that. But I would say that the topic guidance is the only place that notation with the little circle has come up. It's not in the syllabus and it's not in the syllabus glossary. So we're told that the topic guidance is not the syllabus document. So one would imagine that means that that notation is not necessarily going to be used. Finally then, let's look at chapter 5. So this is the extension 1 only chapter. It's quite a large chapter. There are some complicated ideas in this chapter. It's all extra to advanced. It's worth noting section 5a requires trigonometric functions of a general angle, and it requires the Pythagorean identities to fully understand what's going on there. So it could be delayed until after the trigonometric chapter, chapter 6. In fact, the whole chapter could be delayed as it is quite conceptually challenging, but you do need to teach it before chapter 9, which is on differentiation. So let's look at what we're covering. Here is the extension 1 functions topic, and 5a goes through the inequalities section, F1.2. So we've got algebraic and graphical techniques for inequations. We've got quadratic inequalities and absolute value inequalities. 5b talks about tables of signs to look at the zeros and the discontinuities in that function in order to solve inequations. 5c looks at vertical and horizontal asymptotes and then uses that knowledge to help us draw the graph of a reciprocal of a function that we've already got. So let's look at that. This is putting sort of 5a to c together as a integral unit, if you like. So we solve a quadratic inequation, the method for doing that, and here's a nice example that goes through it. And there's a question from the exercise that would help with that. If they can do that, it should be on the right track. Also, absolute value inequations, and solving those inequations which have a variable in the denominator by multiplying through by the square of the denominator. So there's some complicated ideas there just to get their heads round. And here's a question, 2 questions in fact, to help with that focus. 5b then, thinking about where can a function change sign. So where can it cross over from one side of the x-axis to the other side of the x-axis? So either there is a 0 or there is a discontinuity for that to be able to happen. So it talks here for the first time about continuity. We mentioned that earlier in the topic guidance issues for advanced functions. Here's an example that goes through that idea of doing a sign table of signs, and works through that. It's a nice example to give them. Here's a couple of questions from the end to practice that are very similar, or the first one very similar to that example. Then we go on to 5c, where we're going to start look at these limits of the curve approaching the x-axis on the left or on the right, and also looking vertically. and what happens to the table of signs at that point. So again, tricky concepts here. Take your time. And summarising that, testing for vertical asymptotes. And the first question in the exercise on this actually would be very valuable to just get their heads around, to really go through it step by step before then trying some other ones. Also going on to sketching the reciprocal of this given graph then and how that works. And here's a couple of questions that goes through that. So then the next unit would be 5D and 5E together, which is looking at further transformations of graphs. So 5D is basically taking f of x and g of x, drawing the sum, difference and product of those functions. And 5E is doing the graph of the absolute value of a given function and the square root of a given function. So this is the sort of thing that we want to do, and you might even want to be doing this in Desmos, or certainly doing it in the board with lots of coloured pens. The idea that you're looking at the ordinates of f of x and g of x, and then considering what then happens to each of those ordinates if we were to add them, or indeed looking at the other ideas, take them away, multiply them. It goes through how to do each of those things in a detailed table and talks about what happens in those special cases. So vertical and horizontal asymptotic behaviour goes through that carefully. Here are some questions from the end exercise. And then we move on to 5E. So for 5E, we're looking at sketching the absolute value. And here we're going to using reflections again. Goes through carefully these two arguments. So I pick out this bit particularly from the book about if the graph is above or on the x-axis, f of x is positive or 0 and the graph's unchanged, but when it's below the x-axis it's negative and therefore reflected up back above the x-axis. Goes through those things here. And here's a nice question that does all of those things with the same graph. Then we move on to the square root of a sketched function, and again go through that very carefully. It might be that you want to put together all these different summaries in some sort of little booklet or equivalent. Could be an interesting class discussion exercise. What's the same and what's different about all these different lists of sketching and ways of sketching? How can we remember them? What's different? And here's a question from that exercise. And another one. 5f and 5g form another unit of inverse relations and functions. So introducing that idea. You may remember this follows on from what we were doing earlier in chapter 3. 3i particularly, the idea of the horizontal line test. So we're going to reiterate that here. So introducing the idea of inverse relations, domain and range, and using the horizontal line test. And then in FG, we actually introduce inverse function notation and briefly considers one example of restricting the domain. And here I want to point out that restricting the domain before taking the inverse is not covered here, but it will be needed for inverse trig. So we cover it in 17a. Consider your class. It could be that you want to move 17a forward and teach it at this point, or it could be that you just want to leave it till later on, at which point you just remind them that they saw it here in 5G. But it's a very basic example done at this point in terms of restricting the domain. So we go through those inverse relations. Domain and range equation, how to do that, and so on. So notice that to start with, we don't talk about inverse functions, we talk about inverse relations to start with, and we get clear about how to find an inverse relation. Go through all that. Here's a couple of questions you could do at that point. Then we establish if that inverse relation is a function. And we remind ourselves of this table that we had back in 3i. Here are the two questions that might help with that from the exercise. And then in 5G, we're going to establish the notation. Be careful, make sure that you don't confuse it with the reciprocal. And also talk about an identity function when you maps back to itself. So as we've already covered composite functions, we can then say that you could have f to the minus 1 of f of x is x, and similarly the other way around. And get them to discover that themselves, perhaps by just looking at example 21, even try and get them to work through it themselves. And here's a question from the exercise. Here is the more simple example that I talked about earlier. This is the example that they give at this point. And as I say, this has gone into in much more detail in 17a. So finally, introducing parameters. Now remember, this section here uses trigonometry functions of a general angle and Pythagorean identities. So you could delay this bit until after chapter 6 on trigonometry. You don't have to do it now, but if you want to, then great. What we're doing is we're introducing the idea of parameters, parametric equations, and how to find a Cartesian equation. And particularly looking at parabolas, circle and rectangular hyperbolas as those examples to work with for that. So this is a good example of the parameter and goes through that, considering it in terms of a projectile. That would link nicely later on to when you're doing projectiles in vectors. Goes through parameters and finding the Cartesian equation. And these two questions you could perhaps work together through as a class just to illustrate that even more clearly. The topic guidance elephant in the room for functions extension 1. One of the things it says is coverage of the behaviour of functions its tangent at this point, using language including increasing, decreasing, constant, stationary, etc. may need to be explored. Notice it says may. All of that is covered in depth in differentiation in calculus later on. We don't in the textbook talk about that too much at this point, as we feel we're introducing enough at this moment, and they will then be able to in the future, once they have covered the differentiation chapters, be able to come back and talk about functions in that way. Another issue, in section F1.2 on inequalities, there are several points, in fact almost half a page worth of points, referring to the graphing of inequality regions on the number plane. And there's an example given in the suggested questions as well. Now, graphing of inequality regions isn't mentioned in the syllabus, and it's not in the K to 10 syllabus. So we're unsure if this is an oversight or not, but we're also told by Nessa the topic guidance documents are not in the syllabus. It's clearly not in the syllabus, but we feel it might be wise to perhaps use graphing technology such as Desmos to demonstrate just a couple of inequality regions to students in class. They get the idea, the basic idea of it anyway. And we'll provide a Desmos activity in the interactive textbook to cover that, so you could use that.
Well, I hope you've enjoyed the video. I just want to say a little bit about other resources available through Cambridge that you will hopefully find very useful when you're trying to implement this. We want to make life as easy as possible for you while you're implementing this new programme, new syllabuses. Under teacher documents, teacher resources, on the interactive textbook there are curriculum grids, there are teaching programmes, and there is the author's rationale, which I've referred to a few times during this video, and it's there in more detail for you to have a look at carefully. For students in the interactive textbook online, there are videos for all the worked examples, and that offers extra tips and hints that's not given in the printed example. There are also Desmos activities. We talked a bit about Desmos during the video, And those activities have been set up using the graphing calculator to show various concepts, and the students can change the parameters and sliders there within the activities, and you'll have seen how important that could be in trying to illustrate some of these points. There are worked solutions provided for all the exercises in the textbook, including the chapter reviews. Those are not available to the students, but they can be if the teacher enables access for the students. There are also automatically marked multiple choice questions available for all the students. And there are workspaces for all the questions in the textbooks where the students can submit their working or answers to the teacher, and they can also self-assess and indicate the level of confidence in their answer, a traffic lighting exercise if you like we talked about for chapters 1 and 2. There are extra questions that are not in the textbook in the form of a chapter test for each chapter. And those are only accessible to the teacher, so you could choose how you wish to use those questions. At the end of each chapter, you may have noticed just before the chapter review exercise, there's a suggested review activity, which is to make and submit their own summary of the chapter. And we've provided for teachers an editable model version of this in both Word and PowerPoint that you might wish to use. Please do contact your Cambridge Educational Consultant for any additional help and to submit your feedback about this video or anything indeed. We'd be very interested to hear from you.